So stoichiometry is a lot like using a recipe. So say we have a recipe here, you have 3 cups of flour plus 2 eggs, end up making 4 pancakes. So what happens if you want to make 8 pancakes? Say you're having some company and you want to make 8 pancakes. How many cups of flour are you going to need to make 8 pancakes? Well, obviously you doubled the batch here from 4 to 8, so you're going to double everything here. You're going to end up with 6 cups of flour plus 4 eggs makes 8 pancakes. This is stoichiometry. The way we're going to do it though is based on dimensional analysis. But this is easy because it's obvious. You're doubling this, so you double everything else. But when it's not so obvious, say you want to make 14.5 pancakes. All right, how many eggs are you going to need in that case? So the way to do this is dimensional analysis. So you always start off with what we're given. Our question says we want to make 14.5 pancakes. How many eggs are we going to use? So if we have 14.5 pancakes, you start off by writing that down. Then down here, just like we've done before a million times, if you have the unit of pancakes on top, the unit of pancakes goes on the bottom. We're looking for eggs in this case, so we'll put eggs up top. Now, this step here is called the mole ratio. We're going to use this in every single stoichiometry problem we do. We're going to use these numbers from our equation. So the 4 pancakes goes down here. It's equivalent to 2 eggs. That goes up here. So we're always going to have this mole ratio step. Now you simply do the math. Remember, pancakes will cancel out. So 14.5 times 2 is going to be 29 divided by 4. This is a multiplication type problem, so we're multiplying across. 29 divided by 4, 7.25. So we're going to end up using 7.25 eggs if we want to make 14.5 pancakes. This is stoichiometry. We could also figure out how many cups of flour we're going to use. So let's start off with 14.5 pancakes. So we want pancakes on the bottom, so we're going to use the 4 pancakes on the bottom. And this time we're interested in the flour, so we're going to use this 3 up top, 3 cups of flour. So 14.5 times 3. 43.5 divided by 4. We're going to get 10.9 cups of flour. So there we go. If we're going to make 14.5 pancakes, we're going to need 7.25 eggs and 10.9 cups of flour. Stoichiometry, very useful in the real world and in chemistry. Another part to stoichiometry is understanding that this has to do with the conservation of matter. You can't lose matter when you're making chemical reactions. Everything has to be accounted for. So I just want to prove to you how this is so. We're going to use our favorite equation, grams equals molar mass times moles. So let's figure out how much water we have here. So how many grams of water would this be? So we have grams equals the molar mass of H2O is 18. The 2 here represents our moles. So over here we have 36 grams. Okay, let's do the same thing for the hydrogen. Grams equals molar mass times moles. So we're looking for grams. The molar mass of H2, just do the H2, that's 2. And we have 2 moles of that. 2 times 2 is 4. And let's do the oxygen. Grams equals molar mass times moles. grams equals the molar mass of O2 is 16 times 2 is 32. And there is 1 mole here. If there's no number, that means it's 1. So this comes out to 32 grams. So now, check this out. Here are the reactants. The reactant side is 36. If you start off with 36 grams of water, you're going to get 4 grams of hydrogen, 32 grams of this, which equals 36 grams. These are the same number, conservation of matter. So let's go on to some mole-to-mole calculations. These are the easiest of them all, and these are only one-step problems. If you have the word moles and moles, you're converting from moles to moles, you only have to do one step. So, as with all these problems, you always start with the number. Look, where is there a number up here in this equation, in this question? Right here, 10 moles. That's where we need to start. 10 moles of oxygen. Okay. Our next step, or really our only step, is the mole ratio step. So, if you have moles of oxygen here, you need moles of oxygen down here. Where's your moles of oxygen? Here it is, at 5. That goes here. So remember, this mole ratio step, mole ratio, always comes from your equation. You're always going to use these coefficients here. So the question says how many moles of water? We're looking for water. Here's our water, the 4. That goes up top. 4 moles of water. Look what happens. Moles of oxygen cancels. Moles of oxygen cancels. You do the math. 10 times 4 over 5. 40 divided by 5. This comes out to 8 of water. Because this is our unit here. Moles of water. That's what we end up with over here. This is our final answer. And that kind of makes sense. Look what happened. We went from 5 moles of oxygen to 10. We wanted 10. Based on our recipe, we ended up doubling it. So it makes sense that we would end up doubling the 4 to get 8. But we just did this in dimensional analysis. You should do it that way so you don't make mistakes, which are very easy to do when you have these calculations, and especially when you have multi-step ones. This was only one step, so this is pretty easy. Let's try another mole-to-mole calculation. This should also just be one step because it says how many moles of magnesium are needed to make 3.7 moles of iron. All right, so we're going to start with the number. There's only one number up here. It's 3.7 moles of iron. It's a good idea to get into the habit of writing your units so you don't forget what you're doing, because here, if we have moles of iron here, we need moles of iron down here. We're going to use our formula. Where's iron? It's talking about iron. It's all by itself. Don't try to use this one. This is iron chloride. This is just asking about iron. So we're using this too. How many moles of magnesium? Here's the magnesium. There's more magnesium here, but this is just asking about the magnesium that's all by itself. So this 3 is going to go here. Okay, moles of iron cancels. Our units are moles of magnesium, so let's do the math. 3.7 times 3. 11.1 divided by 2. 5.55 moles of magnesium. That's our final answer. All right, so if you're trying to do this in the lab, this is what you would have to do. If you wanted to make 3.7 moles of iron, here we're making this here, how much magnesium are we going to need to put in our reaction? this tells you we're going to have to use 5.55 moles of magnesium, and that'll get us to 3.7 moles of iron. Okay, those mole to mole problems were pretty easy, so let's move on to moles and grams. Because we're dealing with grams, don't forget we're going to need to use this equation. Again, anytime you're dealing with grams and doing chemistry calculations, you're going to have to use grams equals molar mass times moles. So there's a couple different ways to do this. I'll show you the step-by-step method at first, and then I'll show you a dimensional analysis way to do this, kind of all in one shot. So let's go step by step. How many moles of hydrogen? So we're looking for moles of hydrogen here. So I'm just going to put moles with a question mark of hydrogen, because that's what we're looking for. We're starting off with, we have 500 grams of this methane, 500 grams. So this kind of summarizes what we're doing here. We have 500 grams of this, we're looking for moles of this. So again, you're going to want to start off with a number, 500 grams. Now the trick to doing these problems is this. Just like when we're doing mole problems, is you have to get to moles. Get to moles first. Very, very important. Because if you're stuck, you don't know what to do, where to even start off with, this is where you start. You want to get to moles. If we start with 500 grams, here's our equation to get it to moles. So we need the molar mass of CH3OH. So let's see, we have 12 plus 3 plus 16 plus 1. This comes out to 32. That's the molar mass of CH3OH. So here we go. Grams equals molar mass times moles. Let's solve for moles. 500 divided by 32. Remember, you want to divide by the side where your unknown is, because you want to get it alone. So 500 divided by 32. This comes out to 15.625 moles of CH3OH. Okay, so all we did was converted 500 grams to 15.625 moles. So now comes our mole ratio step. That's always the second thing we do. It was the first thing we did in the previous problems because we started at moles. We were already at moles, so we got to moles first. We were already in moles. So now comes the mole ratio. If this is moles of CH3OH up top, we need CH3OH on the bottom. We come to our equation. This 2 is going to go here. The question says we're looking for moles of hydrogen. That's going to go up top here. And we're going to use the 4. This is 4 moles of hydrogen up top. Do the math. 15.625 times 4 divided by 2 comes out to 31.25 moles of hydrogen. Let's look at what happened. Moles of CH3OH canceled. Numbers stay there. Our unit is in moles of hydrogen. Because the question asks us for moles of hydrogen, we're done. That's our answer. So this was 2 steps. We got to moles first, and then we did our mole ratio step. These are all going to have the mole ratio step. It's what stoichiometry is about. Okay, let's try another one. This time we're going from grams of something to grams of something else. This is going to be a 3-step problem because the first thing we want to do is get to moles. We're going to have a mole ratio step, and then we're going to finally calculate our answer. So there's the 3 steps we're going to do. So as always, we're going to start off with a number here. Where do you see a number? Here's a number, 76.5 grams of ammonia, NH3. Grams equals molar mass times moles. Let's write that up here again so we don't forget. So the molar mass of NH3, we have 14 plus 3 is 17 times moles. Solve for moles. Let's divide these by 17. This is 4.5 moles of NH3. So again, we converted, all we did here is converted from grams to moles. We got to moles first. Step 2, mole ratio. So we're going to use our equation. Here's the NH3. We're going to use this 2 here. 2 moles of NH3. Again, write your units down. It'll help you not make mistakes. And we're looking for grams of HF. So in our mole ratio step, we need the 6 here because that's what we're looking for. We're going from ammonia to HF. So 6 moles of HF. Do the math. 4.5 times 6 divided by 2 comes out to 13.5. This is moles of HF. Because look what happened. The moles of NH3 cancel, moles of HF. That's what we did. All right, so all we did was converted the moles of ammonia to moles of HF. And it's all based on our recipe up here. All right, we're not done yet though. This was step 1. This was step 2. Step 3 is getting our final answer. So it asks for grams of HF. So guess what? We're going to use grams equals molar mass times moles. Here's the moles over here. 13.5. The molar mass of HF. F is 19, H is 1, so that's 20. All we have to do is multiply 20 times 13.5, 270. So there we go. There's our final answer. This is going to be grams of HF. Okay, so if you start off with 76.5 grams of ammonia, you're going to end up making 270 grams of HF. So you can see how important this is in chemistry. You know, if you're a scientist, you're a chemist, and you're working in a lab, and you need to make some hydrogen fluoride, these are your starting materials over here. This is what you're going to have to do. Say you have tons of fluorine, you mix it with 76.5 grams of ammonia, you mix it up, you're going to end up getting 270 grams of hydrogen fluoride. All right, I'm going to show you the same problem, but I'm going to do this in one long dimensional analysis. You can do it either way you want. You'll get the same answer. Some people like it the way I just showed you in 3 different steps. Other people, especially if you're good at math, if you're strong in math, then this may make more sense. But we're going to start the same way. We're going to have 76.5 grams of ammonia. And we're just going to jump right to dimensional analysis. So the molar mass of ammonia is 17 grams per 1 mole. Okay, look what we did here. We had grams of ammonia here. These units are going to cancel, is equivalent to 1 mole of NH3. All right, now comes our mole ratio step. Our NH3 is right here. That's going to go on the bottom. 2 moles NH3 is our mole ratio. We're going to HF, so the 6 goes up here. 6 moles of HF, and then we're going to keep going. I'm kind of combining all 3 steps into one. So now we're at moles of HF. We're trying to get to grams of HF. So 1 mole of HF is how many grams? It's the molar mass, which we calculated. It's 19 plus 1 is 20. There you go. Now you have to do the math all across the top here. So we're going to go 76.5 times 1 times 6 times 20 divided by everything on the bottom. 17 times 2 times 1. This comes out to 9180 on top. 17 times 2 times 1 is 34. So we got the same answer as we did before, but this is another way to do it where you're just doing all the calculations as one long dimensional analysis problem. You can do that or the way I showed you a second ago. Okay, let's try another problem here. This time we're going from moles and liters. So remember, we learned that 1 mole equals 22.4 liters. We're going to end up using that information to solve this problem. So again, we're going to start off with the number up here. There's only one number here, 8.7 liters of oxygen. Okay, and what is our main rule? Get to moles first. Get to moles first. Very important. Okay, so how do we convert liters to moles? We use this up here. So if this is liters of oxygen, we want the 22.4 liters on the bottom is equivalent to 1 mole. This is how we convert liters to moles. So 8.7 divided by 22.4, 0.389. This is moles of O2. Okay. It's asking us for moles of Al2O3. So now we go to our mole ratio. Remember, once we get to moles, the mole ratio is next. So we have moles of oxygen on the top. We need moles of oxygen on the bottom. Let's go up here to our formula. Here's the 3 moles of oxygen. We're looking for Al2O3, so we're going to put the 2 moles up here. Al2O3. Let's do the math. 0.389 times 2. Our answer is let's make it 26 moles Al2O3. To ask for moles, we're done. Okay, that was really only 2 steps. So not too tricky there. If you want to do it in all one shot, you do it all in one shot. 8.7 liters of oxygen. 22.4 liters is 1 mole of oxygen. Keep going, dimensional analysis. Here's our mole ratio step. Moles of oxygen on top, moles of oxygen on the bottom. We're going to use the 3. And we're looking for Al2O3. That goes there. This is moles. And because it's moles, the question asks for moles, we're done. So same thing, 8.7 times 2 divided by 22.4 times 3, and we get the same answer. Okay, so 2 different ways to do it. You can do it step by step, getting to moles, doing a mole ratio, or you can do your dimensional analysis all in one shot and just do your math when you come to the end. Let's try this one. Now we're dealing with molecules and grams. So whenever we're dealing with molecules, remember this, 1 mole equals 6.02 times 10 to the 23 molecules. Remember, molecules, atoms, it's whatever you're talking about. This case we're talking about atoms, but we're still using this number. We're using Avogadro's number. All right, so let's do it step by step. First of all, we're going to write it down a number. Here's our only number. 13.7 times 10 to the 24 atoms of magnesium. Get to moles first. How are you going to get this to moles? You have to do a conversion. If we have atoms of magnesium up here, we need Avogadro's number down here. 6.02 times 10 to the 23. atoms is 1 mole. That's how you convert atoms to moles. So do this math, 13.7 times 10 to the 24 divided by 6.02 times 10 to the 23. It's going to be 22.8 moles of magnesium. Okay, so we got to moles. Now we do our mole ratio. We have 22.8 moles of magnesium. Comes our mole ratio step. So the magnesium is right here. We're going to use the 3 moles of magnesium. The question says we want grams of iron. So we have to go to iron. Here's the iron here that's by itself. Don't use this one here. We want the one that it's telling you specifically. So we want the 2 from the coefficient from the iron. So 22.8 times 2 divided by 3, 15.2. This is moles of iron. And then finally, it's asked for grams. The question says grams of iron. So we have to go grams equals molar mass times moles. The molar mass of iron is 56. Moles we just solved for. 15.2, 851. All right, so if you're a chemist, this is what you would end up doing. If you want to do this in one giant step, this is how we would do it. Start off the same way, 13.7 times 10 to the 24. This is atoms. Why is my thing not writing great? Atoms to moles. 6.02 times 10 to the 23. Atoms is 1 mole. This is magnesium. Mole ratio. Magnesium is going to go on the bottom. 3 moles of magnesium. We're looking for the iron. That's 2. And then finally, we're looking for grams. So we're in moles of iron. 1 mole of iron is how many grams? It's the molar mass. So there you go. You can do it either way, whatever way makes you happy. And of course, we'd come out with the same answer. You multiply everything on top, divide by everything on the bottom. All right, so 2 different ways to do it. You could do it the step way, 1, 2, 3, or you could do it one giant step doing dimensional analysis. Okay, let's try another one. This time we're going to go from using liters and grams. We could do this all day long. You just have to remember, if you're dealing with liters, again, 1 mole is 22.4 liters, and grams equals molar mass times moles. So you're going to end up using both those things if that's what your question is about. Liters of oxygen, grams of water. All right, so if you want to visualize it, we have 5 liters of oxygen, and it's asking us for grams of water. That's what the question is. Okay, so as usual, let's start off with a number, 5 liters of oxygen, get it into moles. If we have liters of oxygen there, we need it down here. 22.4 liters is 1 mole. I want to keep going. I want to do it the one-step way right here. Moles of oxygen. Here's our mole ratio. Let's use the 5. And we're interested in the water, so we're going to use the 4. Okay, I want to keep going. We're in moles of water, so 1 mole of water is how many grams? It's the molar mass. There you go. Do the math. 5 times 1 times 4 times 18 divided by 22.4 times 5 times 1. 3.2 grams of H2O. All right, so if you started off with 5 liters of oxygen, all you're going to make is 3.2 grams of water. That's the one-step dimensional analysis way. Let's try this 1, 2, 3 method. Step 1, get to moles first. We have 5 liters of oxygen. 22.4 liters is 1 mole. You can do the math right now. 0.223 moles of O2, mole ratio. We have oxygen on top, so we need the 5 moles of oxygen on the bottom. We're going to moles of water. 2.23 times 4 divided by 5, 0.179 moles of water. This was step 2. And step 3 is getting it to grams. Grams equals molar mass of water is 18 times 0.179. 3.2. Either way, do whichever way you want. And why not? Let's try a liters to liters calculation. Again, 1 mole is 22.4 liters. Start off at the beginning, 12 liters of water. Get to moles first. We want the 22.4 on the bottom because we have liters on top here. Is 1 mole. Let's do it the one long step way. So now we have moles of water, which is the 4 that goes on the bottom. And it says we're looking for liters of oxygen. Here's the oxygen. The 5 goes on top. And then finally, it's asking us for liters. So if we have moles of oxygen here, we want 1 mole of oxygen is 22.4 liters. Do the math. 12 times 5 times 22.4, 1344. Divided by 22.4 times 4, 15 liters. Okay, if it's a liter to liter problem, you can forget about doing this part and this part, because notice how those would just cancel out anyway. This is just a trick. If you remember, if it's liter to liter, you can just do a one-step calculation going from 12 liters to the mole ratio step, and you're going to get the same answer. Okay, because if you're doing liters, look what happens. The 22.4 from here ends up canceling with this. The moles of water cancels with the moles of that. So this is what you're left with. It's just a quick trick if you can remember when you're doing liter to liter problems. And let's just do one more problem dealing with moles and molecules. Again, 1 mole equals 6.02 times 10 to the 23 whatever. We'll just say particles. Okay, so we're starting with moles, 7.2 moles of BeO. Get to moles first. We're already in moles. So if we're already in moles, go right to the mole ratio step. Moles of BeO, here it is, it's 1. And we're looking for molecules of SRO. So SRO is here. Our mole ratio will be 1 for that. So you end up getting 7.2 moles of SRO. Okay. And now finally, let's get that into molecules. If this is moles of SRO, we need 1 mole here and 6.02 times 10 to the 23 up top. 4.4 times 10 to the 24 molecules. Okay, so just some final tips. Formulas you're going to need to know. Grams equals molar mass times moles. You need to know that 1 mole equals 22.4 liters. And you need to know 1 mole equals 6.02 times 10 to the 23 particles. This could be atoms, it could be molecules, it's whatever it is you're talking about. All right, so tip number 1 is always start with a given number. You want to get it to moles. You want to do a mole ratio step. That is the thing about stoichiometry. It's what makes stoichiometry, because you need the mole ratio from your equation. And then finally, you're just going to solve for whatever your unknown is in your problem. All right, that's it. Stoichiometry, not too bad. It takes some practice. It's really just converting one thing to another. Super, super important in chemistry.